Hello everyone, and welcome to a new video in our series on fractions. First and foremost, fractions are of the form A over B, where A is the numerator and B is the denominator. Now, there are a few conditions that are necessary to prove or to verify if we actually have a fraction. First and foremost, A will not be equivalent to B, because if we had a fraction where the numerator and the denominator are both equal, then it's not a fraction, because you and I know that any number that is divided by itself will give you 1, and 1 is not a fraction. Another rule we will have is that B is not equal to 0. So we know that if you divide any number by 0, you're not going to get a real number. So therefore, we can't have a fraction with the denominator as 0. So these are just two conditions for you to keep in mind. Now, we have three types of fractions. We have proper fractions, we have proper fractions, we have improper fractions, and we also have mixed numbers. Now, examples of proper fractions will include, 2 over 3, and for example, you could also have 5 over 9. An example of an improper fraction will include something like 3 over 2, and you could also have 29 over 5. Examples of mixed numbers could include 1 whole number, 2 over 3, and you could also have 3 whole number, 5 over 7. Now, these are examples, but to explain it better, you'll notice that for our proper fractions, the numerator in each case is less than the denominator. The numerator is less than the denominator. When you have a fraction of the form, of such a form, where you have the numerator being less than the denominator, you could categorize it as a proper fraction. Now, for improper fractions, the numerator is greater than the denominator in both cases. So when you have a fraction where the numerator is greater than the denominator, you could categorize it as an improper fraction. Now, for our mixed numbers, you have a case where our expression has a whole part and a fractional part. For example, you see this as a whole part, and this is the fractional part. So, when you have this kind of mix, when you have a whole part and a fractional part, you call them mixed numbers. We have 1 whole number, 2 over 3. So that has a whole part, which is 1, and a fractional part, which is 2 over 3. Now, the basic arithmetic rules of addition, subtraction, division, and multiplication applies to fractions. Now, if we are to perform more than one operation of the aforementioned, then BODMAS patterns must be strictly adhered to. In some other areas, you call it PEMDAS, just depending wherever you are. Now, let's start solving problems. We have simplify 10 whole number 2 over 5 minus 6 whole number 2 over 3 plus 3. So first and foremost, we begin by converting our mixed numbers to improper fractions. And to do that, we're going to multiply our whole number, which is 10, by 5. Now if you multiply 10, which is the whole number on the first fraction there, by 5, we will have 50. And when we add the numerator, which is 2, to it, we're going to have 52 over, our denominator always stays the same, so 52 over 5. Now we're going to do the same for the second fraction. We'll multiply the whole part, which is 6, by the denominator, which is 3, and then we add the numerator to it, and that's 2. So if we multiply 6 by 3, we have 18, and if we add 2 to it, we have 20. We have 20 over, and the denominator always stays the same. That's 20 over 3. Now, that's plus. The last value there is what? Is 3. So if you have 3, you know that 3 is the same thing as 3 over 1, because any number you divide by 1 will still give you that same number. So now we've done this, we can move on to simplify further by finding the lowest common multiple of the three fractions we have. Now if we find the lowest common multiple of 5, 3, and 1, what are we going to get? We're going to get 15. Now if you want to know how we got 15, there's a simple way to do it. The largest is actually 5. The largest number among all of them is 5. So we can simply say 5 times 2 will give us 10. Now, can 10 be divided by 3? It can be divided by 3. Can it be divided by 1? Yes, of course, any number can be divided by 1. But since it cannot be divided by 3, then we can assume that 10 is not the LCM of the three numbers. So we take that, our highest number, which is 5, and we add it again to 10, and we have 15. Now 15 can be divided by 5, it can be divided by 3, it gives us 5, and it can be divided by 1. So therefore 15 is our LCM. That's just a simple way of finding an LCM without having to write down, so many things. So now we have 15. So we'll first of all begin our process of subtraction and addition of our three fractions right here. So if we divide 15 by 5, which is the first denominator here, if we divide 15 by 5, what are we going to have? We'll have 3. Now, are we going to put 3 down? We won't do that. We'll multiply the numerator by 3. And if we multiply 52 by 3, what are we going to have? We're going to have 156. Now, our subtraction sign. We're going to repeat the same process on the second fraction. Now we're going to divide 15 by 3, which is the denominator there. And if we divide 15 by 3, we're going to have 5. Now we'll multiply that by 20, and 5 times 20 will give us what? Will give us 100. We'll put up our addition sign, and we repeat the process again. If we divide 15 by 1, we're going to have 15. And if we multiply 15 by 3, we're going to have 45. So we have 45 right here. Now, at this point, everything is already almost completed. We simply subtract and add where necessary. So 156 minus 100 will give us 56. And 56 plus 45 will give us 101. So we simply have 101 over 15. And this is an improper fraction. But that's our answer. Okay? That's our final answer. Now, we can actually convert this to a mixed number if we want to do that. It's very simple. We're going to find out how many times 101 can be divided by 15, and then that will become our whole part, and then after doing that, we'll have the remainder as our numerator, and our denominator will always stay the same. So if we do that, we're going to have 101 divided by 15 will give us 6 whole number, because 15, there are only 6 wholes of 15 in 101. So you're going to have 6 whole number, and the remainder will be 11 over, our denominator always stays the same, 15. So we've converted it to a mixed number. Now let's take another example. You have simplify 1 whole number 3 over 4 minus, in bracket you have 2 whole number 1 over 3 plus 4. So to do that, we're going to start by converting our mixed numbers to improper fractions, and that's going to give us 1 times 4. For the first fraction, you have the whole part, which is 1 times 4, the denominator, and that's going to give you 4. If we add the numerator to that, we're going to have 4 plus 3, and that will give us 7. So automatically, we're going to have 7 over, our denominator always stays the same, and that's going to give us 7 over 4. Minus, we have a bracket. Now we're going to convert 2 whole number 1 over 3 to an improper fraction, and we'll multiply 2 by 3, and we're going to have 6. And if we add the numerator, which is 1 to 6, we're going to have 7 over 3. And we add what? We have 4. Now remember, 4 is the same thing as 4 over 1. And so therefore, we've simplified our expression further. Now, if we simplify, if we move further, we're going to have 7 over 4 minus, now because we have a bracket, we'll have to solve what we have in our bracket first. Follow the order of operations by solving what we have in our bracket first. And therefore, we're going to be looking for the LCM of 7 over 3 and 4 over 1. And the denominator we have is 3 and 1. So therefore, our LCM is going to be 3. Okay? Lowest common multiple is 3. Now, if we divide 3 by 3, we're going to have 1. And if we multiply 1 by 7, we're going to have 7. Okay? Now, we'll repeat the same process for the next fraction. If we divide 3 by 1, we're going to have 3. And if we multiply 3 by 4, we're going to have 12. Okay? So we have 7 plus 12 over 3. Now, if we simplify this further, we have 7 over 4 minus 7 plus 12 will give us what? It gives us 19 over 3. And that's what we have. Now, if we move on to simplify what we have further, we'll need to find the LCM of 4 and 3, so we can subtract our fractions. And the LCM of 4 and 3 is going to give us 12. Now, if you wonder how we got 12, you know the larger denominator here is 4. If you multiply 4 by 2, you have 8, and 8 cannot be divided by 3. Now, if you multiply 4 by 3, you have 12, and 12 can be divided by 3. So therefore, 12 becomes our LCM, a new denominator. So when you move on with that, we say 12 divided by 4, you're going to get 3. 3 multiplied by 7, you're going to have 21. So we have 21 minus, then you have 12 divided by 3, you're going to have 4. 4 times 19, and you're going to have 76. So therefore, we have 21 minus 76. And when we subtract that, we're going to have, this will give us 55 minus 55 over 12. And that's actually our answer. But since this is an improper fraction, because we can see that the denominator is less than the numerator, so actually it's an improper fraction. So we won't just leave it this way. We're going to put it in the form of a mixed number. And to do that, we're going to say 55 divided by 12. And what do we have? Minus 55 divided by 12, we're going to have minus 4. That becomes a whole number. Okay? The remainder is what? The remainder is 7 over 12. And this is our final answer. minus 4 whole number, 7 over 12. Alright, now we have another problem here. It says simplify 1 whole number 2 over 3 of 2 whole number 1 over 4 divided by 3.5 minus 1 whole number 1 over 4. Now, to solve this problem, we'll simply begin by converting our mixed numbers to improper fractions. And we can write that out, we can rewrite that as, you have, for the first one, we have 1 whole number 2 over 3. So if we multiply 1 by 3, we have 3, and if we add that to 2, we're going to have 5. So we're going to have 5 over, we're going to have 5 over 3 of, now we have 2 whole number 1 over 4. So if we multiply 2 by 4, we have 8, and if we add 1 to that, we have 9. So we're going to have 9 over 4. Now, we're moving on. We have the next one there. We have 3 whole number 1 over 2. So if we multiply 3 by 2, we have 6, and if we add 1 to that, we have 7. So we're going to have, this is going to be divided by 7 over 2. Finally, we have our last mixed number there, which is 1 whole number 1 over 4. So if we multiply 1 by 4, we're going to have 4. And if we add 1 to that, we're going to have 5. So we're going to have minus 5 over 4. Now, following the order of operations, board mass or PEMDAS, depending on which you're more conversant with, we have to attend to this one first, which is the first one there, which is 5 over 3 of 9 over 4. Okay, that's the first thing we're going to deal with. And therefore, to do that, we can move further. We're going to have 5 over 3. Now, of in mathematics, the same thing as multiplication. Okay, so 5 over 3 times 9 over 4. We can enclose this in a bracket so we're very clear that we're handling this first. Is divided by 7 over 2 minus 5 over 4. Now, to complete the first step, which is dealing with the off, we're going to deal with, we'll simply move further, and we're going to say, let's deal with what we have in the bracket first. And to do that, we can cancel out. We have 3 here. If 3 is divided by 3, we're going to have 1. And if 9 is divided by 3, we're going to have 3. Okay? So, we're left with 5 over 1 times 3 over 4. If we multiply through, we have 5 times 3. We're going to have 5 times 3 and 1 times 4. So let's do that. We have 5 times 3, that's 15 over 4. Now, divided by 7 over 2 minus 5 over 4. Now, if we move further, we can simplify this by, first of all, dealing with the division part of our problem. Because from board mass, division has a higher precedence than minus. So, we can do that. We'll simply have, this will give us 15 over 4. Okay. Now our division sign will become a multiplication sign. And when that happens, the fraction at the right hand side of the division sign will be flipped. Our numerator will become our denominator and vice versa. So we're going to have a multiplication sign here. We're changing the division sign now. And then we're going to have, instead of 7 over 2, we're going to have 2 over 7 minus 5 over 4. Now we can also leave this in a bracket just to make it clear that we're dealing with this first. Okay. Now if we move on, we're going to have to solve that. We can cancel out. We have 2 here. If 2 divides by 2, we're going to have 1. If 4 is divided by 2, we're going to have 2. Okay. So we're left with 15 times 1 and 2 times 7. So if we multiply 15 by 1, we're going to have 15 over, and if we multiply 2 by 7, we're going to have 14. 15 over 14. Okay? Minus 5 over 4. Now, we're left with just a simple problem subtracting the both fractions. Now, of course, to do that, we'll find the LCM of our two denominators, which is 14 and 4. And when we do that, we easily can tell that our LCM for 14 and 4 will simply be 28. You know, 14, which is the highest denominator here, cannot be divided by 4. So if we multiply 14 by 2, we have 28. And 28 can be divided by 4 and also can be divided by 14, of course. So that can be our LCM. That's our LCM. So now, if we divide 28 by 14, we have 2. If we multiply 2 by 15, we have 3. Okay? So, divide 2 by 15, we have 30. We have 30 minus, if we do the same for the second fraction, if we divide 28 by 4, we're going to have 7. And if we multiply 7 by 5, we're going to have 35. So, this now has brought us to the final part of our problem. And to do that, we simply subtract 35 from 30. And that's going to give us minus 5 over 28. And that's our final answer. It's a proper fraction, so we can leave it in this form. And so we have another problem here. It says simplify this expression. And what we're going to do is that we're going to rewrite what we have here in this form. We'll try to separate the left-hand side of our expression from the right-hand side. And we'll write it like this. We're going to have 3 whole number 2 over 3 times 1 whole number 1 over 8. Okay? And we're going to say this as a whole is being divided by 3 whole number 2 over 3 minus 2 whole number 1 over 4. Now we're going to enclose all of that in a bracket, and this is our left hand side. Okay, this is the left hand side of our expression. And now everything on our left hand side is being divided by, we have our right hand side, and that's 5 whole number 1 over 2 divided by 3 whole number divided by 3 whole number 7 over 9. Now we've done that and we've put everything in a much more organized format. So therefore we have our left hand side and we also have our right hand side. This makes everything simple. So we're going to first of all convert our mixed numbers to improper fractions. And if we do that, we're going to have, open a bracket, we'll have 3 times 3 is 9 plus 2, that's 11. So we're going to have 11 over 3 times
1 times 8 is 8 plus 1, and that's 9. So we're going to have this plus 9 over 8. Okay, remember we organized it this way. So we have, this has been divided by, we have 3 times 3 is 9 plus 2, that's 11 over 3. So we have 11 over 3 minus, we have 2 times 4 is 8 plus 1, and that's 9, minus 9 over 4, minus 9 over 4. And we have done that, so we'll move on to the right hand side, and now we'll have 5 times 2, that's 10, plus 1, that's 11. We have the 11 over 2 is being divided by 3 times 9, that gives us 27, plus 7, that gives us 34. We have 34 over 9. So now we're done converting all our mixed numbers to improper fractions. So therefore, the next step will be to simplify further by solving what we have in the various brackets. So if we do that, we'll start with this bracket, and then we'll do the same for this bracket, and then we can move on. So this will give us, if we move further, we'll have that 11 times 3, 11 over 3 times 9 over 8, we can definitely cancel out. We can see some common factors right there, so we can cancel out. And if we do that, we have that 3 being divided by 1 by 3 will give us 1, and 9 being divided by 3 will give us 3. So therefore we have 33 over 8 is being divided by, when we look at this, we have that 11 over 3 is being 9 over 4 is being subtracted from 11 over 3. So therefore we have to find the LCM of 3 and 4, and that is 12. So we have that this is being divided by, you have 12 right here, and when we divide 12 by 3 we have 4. When we multiply 4 by 11 we have 44. So we have 44 right here, minus, when we divide 12 by 4 we have 3. When we multiply 3 by 9 we have 27. We have 27 right here. We close a bracket, and then we proceed. And so now if we observe this here, you'll notice that this is a division sign. So if you want to divide two fractions, this changes to a multiplication sign, and the fraction at the right hand side will be flipped. So if we proceed with doing that, we're going to have that 11 over 2 times the division sign changes to a multiplication sign, and this fraction flips, and we're going to have 9 over 34. Okay, now that's what we have. So we've come a long way. We can also make some cancellations right there, you know, if there be any common factors, but in this case nothing is actually common, so we can leave it that way. So we're going to have that the next step, we'll have that 33 over 8 is being divided by 44 minus 27 will give us 17 over 12. We have 17 over 12. And this all is what we have on our left hand side now, and this is being divided by, if you multiply 11 by 9 you're going to have 99 over, you multiply 2 by 34 you're going to have 68. So you can see everything now is very much simplified. So if we move on, we're going to have that, let's move on, we simplify this further. We'll have that 33 over 8 is now being multiplied because our division sign becomes a multiplication sign. And when we do that, the fraction on the right hand side will be flipped, and we're going to have 12 over 17. Now, this is all in a bracket, and we have that this is being multiplied. Now, this division sign also changes to a multiplication sign, and this also gets flipped. So we have 68 over 99. Now, if we move further, we can say that we carry out the necessary calculations where necessary. We can actually write this out in a simple, uncomplicated form as this: 33 over 8 times 12 over 17. Since we have the same operators, arithmetic operators on both sides, we can simply write it out without the bracket because the operator precedence is the same. So we have 68 over 99. So now we can cancel out, if 17 is being divided by 17, you're going to have 1. If we divide 68 by 17, you have 4. If we divide 8 by 4, we're going to have 2. And if we divide 12 by 4, we're going to have 3. Now, if we divide 33 by 33, we're going to have 1. If we divide 99 by 33, we're going to have 3. Now, of course, you can see we have 3 up there and we have 3 down there. So if we divide 3 by 3, we're going to have 1. If we divide 3 by 3, we're going to have 1. And if we divide 2 by 2, we'll have 1. And if we divide 4 by 2, we'll have 2. So you see, we're left with just 1 times 1 times 2. And down here, we just have 1 times 1 times 1. Now, our answer is very obvious at this point. If we multiply 1 times 1 times 2, we simply have 2. And that's a final answer. So that's just what it is. Finally, we have a question here. It says arrange 5 over 6, 2 over 3, and 3 over 8 in descending order of magnitude. So to do that, we're going to find the LCM of the denominators of our three fractions, and we'll multiply the three fractions by our LCM, and it will be easy for us to arrange them in descending order of magnitude. So to do that, we know the largest of the denominators here is 8. Now 8 cannot be divided by these 2 wholly without a remainder. So if we multiply 8 by 2, we're going to have 16. 16 cannot also be divided by 3 and 6. There will be a remainder. So we'll multiply 8 by 3 and we have 24. Now 24 can't be divided by 3 without a remainder, and it can't be divided by 6 without a remainder. So that's our LCM. So we proceed by multiplying through, and we have 5 over 6 times 24, which is same thing as 24 over 1. Now when we cancel out 3, if 6 is divided by 3, you're going to have 2. And if you divide 24 by 3, you're going to have 8. Now 8th, if you divide 8 by 2, you're going to have 4. And if you divide, of course, 2 by 2 is 1. So if we multiply that, we have that 5 times 4 gives us 20. And that's for our first fraction. That's our first fraction, okay? Now if we move on, we'll have that for the second fraction, we have 2 over 3 times 24. And when we cancel out, we have that 3 here, gives us 1. If we divide 24 by 3, we have 8. Now if we multiply that, we have that 2 times 8 gives us 16. And this is, of course, for our second fraction. It's for second fraction. Now, finally, for our third fraction, we have the 3 over 8 times 24, and when we multiply through, I have 8 here, that's 1. 8 here, that's 3. We'll multiply that, we'll have 3 times 3, and that will give us 9. And that's for our third fraction. So, we're left with 3 numbers. Finally, we have 20, we have 16, and we have 9. So, we can see that already this represents the first fraction. This is the first fraction. This is for the second fraction. And this is for the third fraction. So if we were to arrange these fractions in a descending order of magnitude, we can already see that they are already arranged in a descending order of magnitude. So to put this in a final form, give a final solution to this question, we'll have that the arrangement in a descending order of magnitude will be 5 over 6, 2 over 3, and 3 over 8. And that's it for this video. Please like and subscribe. Thank you.